Good day, everyone. So today you will going to learn about the shortest job first or the shortest job next. First, let us define what is shortest job first. SJF, so out of all waiting process, so it selects the process with the smallest burst time to execute next. Now we have two terms to consider here. We have the preemptive and the non-preemptive. So when we say preemptive, one CPU cannot remove, we need to wait to finish the process. And when we say non-preemptive, we can remove from the CPU based on the priority. So we have also other terms to be considered in preemptive. We have the shortest remaining time first or the SRTF. Okay? Now, for the non-preemptive, so it is by default process. So how to calculate for the shortest job first? So based from the given table here, so we have the arrival time for P1 to P5 and the burst time from P1 to P5. First, we need to what? To create a Gantt chart. Okay? So since we create here a Gantt chart, so at the CPU at time 0, okay, for our Gantt chart at time 0, we have only one process that is what? That is P4. Again, at time 0, the only process at the arrival time, we have P4. Okay? But we cannot say that directly. We can jump to this verse and check out, of course, the verse shortest time. So, based on the burst time, we have the shortest time here, the P1 and P3. Because their burst time is 1. Okay? If both burst time having the same burst time, then we can use the FCFS or the first come first serve. So means P1, this is not right because we cannot allocate the CPU to either P1 and P3. Why? Because we can say P1 arrival is 2, okay? And the arrival of P3 is 4. So these two process has not come yet at time what? At time 0. Okay? So out of all available process, now at time 0, which process available you have? So to check first of all, the arrival time, only one process, that is what? That is P4. Okay? So we can now write here P4. So the burst time of P4 is 6. Okay? So we have no choice to allocate P4 in our CPU. Okay? Now, even though that the P4 has the largest burst time of this process. So, till burst time of this process is 6, so this would require 6 units of time for completing its execution. So, since we can now, we can write here yung 6, so it is non-preemptive mode. In between the execution, you cannot remove this process from CPU because this is non-preemptive. The assumption is no process would require any input or output device. Only CPU-bound processes we have taken. Now, at time 6, okay, so at time 6, we have to check has come now at time 2 and time 2, time 1, and time 4. So at time 2, we have P1. So at time 1, we have P2. And then at time 4, we have P3. Okay? And of course, once this P1 to P3 is done, we can now have the P5. So all the process has been arrived. We can only say this is in our ready queue. So this is our ready queue. Now we have to apply, of course, the shortest job first, or the SJF. So how to select a process having the shortest first time? So all the available process, we need to pick. So now two processes having the same burst time, we have P1 and P3. Now at time 4, so at time 2, so we have P1 and P3 at time 4. According to first come first serve, CPU would be allocated what? At P1. Why? Because 2 is less than 4. Okay? So since P1 is less than to the arrival of P3, we can now write here in our Gantt chart, the next CPU to be arrived is P1. Okay? So what is the burst time of P1? The burst time of P1 is 1. So 6 plus 1, we have 7. Next to arrive, of course, we have P3. So P3, the burst time of P3 is 1. So 7 plus 1, we have 8. Then the next, so we can now terminate P1. Okay? And we can now terminate P3. Now, what comes next? We have what? We have P2. Okay? Oh, we have what? We have P5 because P5 is, its arrival is 2. So, we can now write here P5. And the burst time of P5 is what? We have 3. So, 8 plus 3 is 11. And the last is P2. The burst time of P2 is 5. Okay, so 11 plus 5, we have 16. Now, P1 is already terminated up to P3, P2, and up to P5. So, is there any time when the CPU was idle? So, no. From 0 to 16, every time the CPU was busy doing the time processing. So, CPU is not idle from starting to ending. So, this total, 16, should be equal to this total of this burst time. If you will add this burst time, so 1 plus 5 plus 1 plus 6 plus 3, this is 16. So, this is equal to our Gantt chart. Okay? Now, we can calculate the all the average waiting time, the turnaround time, the response time. But first of all, of course, we need to what? To determine the completing time or the completion time. So, for the completion time, of course, P1, what is the completion time of P1? The completion time of P1, we have 7. Okay? The next, what is the completion time of P2? So, the completion time of P2, we have 16. The completion time of P3, we have 8. And the completion time of P4, we have 6. The completion time of P5, we have 11. So, since we have the completion time, we can now compute for the turnaround time. So, to compute for the turnaround time, of course, we need to less the, of course, based on our completion time, then minus to the given burst time, or minus give for the given arrival time. So, 7 minus, again, for the TAT or the turnaround time, so completion time minus arrival time. So, 7 minus 2, we have 5. And then, 16 minus what? 1, we have 15. And then, 8 minus 4, we have 4. And then 6 minus 0 is equals to 6. Then 11 minus 2, we have 11 minus 2, we have 9. Okay? Now, since we already compute for the turnaround time, so let us compute for the waiting time. Okay? So, waiting time, of course, is we need to less the turnaround time to the burst time. So, again, we need to, so turnaround time minus the burst time to compute for the waiting time. Okay? So, our turnaround time is 5 less to the burst time, which is 1. Okay, so we have 4. And then 15 minus 5, we have 10. Then 4 minus 1 is equals to 3. Then 6 minus 6 is equals to 0. Then 9 minus 3 is equals to 6. So, after computing for the waiting time, it is time for us to compute for the response time. Okay? So, to compute for the response time, of course, we need to get the value according to our Gantt chart. Okay? So, according to our Gantt chart, okay, so the response time we have here for P1, okay, so our P1 here is, of course, we have 6 minus 2, okay, so our P1 is 6, okay, so P1 is 6 based on our Gantt chart, so 6 minus 2 minus the arrival time, so we have 4. So, P2, what is our P2? Our P2 based on our Gantt chart is 11. Okay? Minus the arrival time, which is 1. We have 10. And then, what is P3 in our Gantt chart? P3 is 7. So, 7 minus 4. Okay? We have 3. Then what is P4? Our P4 is 0. So 0 minus the arrival time, which is 0, is equals to 0. And then what is our P5? Our P5 is 8 according to our Gantt chart. So 8 minus the arrival time, which is 2, we have 6. Okay? So again, to solve for the response time, look at the Gantt chart. What time does the CPU has come in ready state? And check out the arrival time for each CPU. Now, if you look at the waiting time and the response time, they have the same value. Okay? So, the waiting time and the response time always have the same value. So, if we will compute for the turnaround time, the total turnaround time is 39 less to how many CPU that we have here? We have 5 divided by 5. We have 7.8. And for the waiting time, so 4 plus 10 plus 3 plus 0 plus 6, we have 23 divided by the number of CPU, which is 5. So we have 46. So if the shortest job first is non-preemptive, then the waiting time and response time would be the same. Okay? Again, if the shortest job first is non-preemptive, the waiting time and the response time would be the same. So I hope you learned something new on how to compute for the shortest job first using the non-preemptive. So good luck and God bless us.